Okay, so we're going to now talk about titration. And a titration is a laboratory technique in order to determine an unknown concentration. So it's like you know the concentration of the acid in your reaction, and you're trying to determine the concentration of the base in your reaction. I'm going to put a video about titration so you can see somebody doing a titration in the lab setting underneath this video. So make sure that you take a look at that. Titrations use an indicator. So an indicator is something that will change color depending on if it's in an acid or a base. And so what you do is you put your acid in a beaker, and then you slowly start adding base until it reaches the equivalence point. The equivalence point is when you have an equal amount of moles of acid and base. And so the indicator, if we pick the correct one, will change color, called the end point, at that same time as we reach the equivalence point. So right when we get equal amounts, our indicator should indicate that by changing color. Now, there are things called pH meters that we can digitally track the pH, and then we can pull the equivalence point off of that graph of data. So again, you're going to add your known concentration to your unknown concentration, let it fully react, in other words, get equal moles for the equivalence point, and then hopefully the indicator's end point matches the equivalence point. To do the math, we're going to use M1V1 equals M2V2. It's like a dilution problem, except instead of ones and twos, we have acids and bases. So this formula is kind of given to you on page 3 of your reference table. It's just instead of ones and twos, we have acid and base. So if you recall from our dilution problems, we look for the word of. The word of is going to connect our two values. And so here we have the word of. And so I know that this concentration and this volume have to go together. If we actually read the problem will tell you if it's for the acid or for the base. So in this case, it has NaOH following them. So I know that this is my MB, the molarity of my base or the concentration of my base. And then I have my volume of base. Now, it doesn't matter what unit the volume is in, milliliters or liters, as long as they're the same. So since my volume of base is in milliliters, then my volume of acid should also be in milliliters, and then I don't have to worry about converting. So the other number that I'm given is 25 milliliters. Well, if I keep reading, that's the sample of HCl, which is an acid. So this is my volume of acid. The question then is saying, what is the molarity of the HCl solution? So I'm looking for the molarity of my acid. So I'm looking for Ma. So I pull my equation from page 3 of the reference table, change my ones and twos to A's and B's. I plug in what I'm given. To find the molarity of the acid, I need to divide both sides by the volume 25, so that it cancels out over here and I'm left with just the molarity of the acid. Plug that into the calculator. I'm using 4 significant figures because all of these numbers have 4 sig figs. And then if I look at my units, milliliters and milliliters would cancel, leaving me with molarity. So I know that I solved this problem correctly. We're going to look at another example. Here we're titrating nitric acid with potassium hydroxide. So I look for the word of. I know that that's connecting my two numbers. 0.1819 then is the molarity of the base because KOH is a base, it's acidic. It doesn't start with hydrogen, so it's got to be the base. And that would make the 20.05 the volume of the base. The other number, 20 milliliters, sample solution of nitric acid. So the problem is telling me that the 20 milliliters is for my acid. So that has to be my VA. And then it says nitric acid with unknown molarity. So we're looking for the nitric acid unknown molarity. We're looking for M sub A. So I turn to page 3 of the reference table. I pull my titration formula, change the 1s and 2s to A's and B's, plug my values in. To get MA by itself, we'll have to divide by 20 milliliters. When you type that into the calculator, you should get an answer of 0.1824. Notice that it's a really close value to the concentration of the KOH, and that's because the volumes of the two were really close together, 20 milliliters and 20.05 milliliters. So for units, your milliliters would cancel out when you divide them, leaving you with a unit of molarity. So that shows me that we did our math correctly. Try the problems I've given you. Let me know if you have any questions.